Hello everyone, welcome back. This is Labor Economics, Dr. Gevrek, and today we're going to learn more about the compensating wage differentials. This is part 2. So don't forget to watch these videos in sequence, right? I arranged all the videos in playlists by units. So if you're watching this part 2 now and this is the first video that comes your way, I highly recommend you go watch chapter 5 part 1 first. Okay, so a couple of more things. Don't forget to subscribe to this channel so whenever I post a new video you see those, and don't forget to actually hit the like button of this video so that this video reaches to many more students and helps them with their studies to help them earn A's. Okay, let's get started. In this part we'll talk about general model for compensating wage differentials. We are going to talk about market for risky jobs, and we'll also learn about hedonic wage function and hedonic wage theory. Let's get started. Okay, so here's the general model. We're going to talk about a market where there are two types of jobs. One job is a completely safe job. It is what we call safe job. Prob means probability of getting injured is 0. There is no chance you're going to get injured in this job. There is also a risky job. Probability of getting injured is 1. That means you're going to get injured somehow. So one example, last week I was at a committee meeting. I hit my hand. So injury doesn't need to be serious injury, right? I was at a committee meeting. I hit my hand and it was painful. So I got injured, right? I still have some pain. So some jobs are risky, some jobs are safe. Even some office jobs can be considered risky because of, clumsiness. However, when we say risky job, we're talking about in this context. For instance, my job could be considered a safe job versus a construction job could be a little bit more risky. All right, let's get started. So for instance, example is asbestos. We didn't know asbestos was very dangerous before 1960s. Okay, so keep that in mind. And asbestos was used in lots of construction. And once you are, let's say, demolishing something, you're breathing that air contaminated, it affects you, okay? So workers, we talked about this before, but workers care about their safety, about their jobs, okay? And we will assume that workers have full information on the riskiness of a job. So they don't just go into a job blindly, okay? So their utility depends on wage rate, that's something positive, and the risk of injury. As risk of injury increases, their happiness goes down. So I want to just remind you something. So remember, this was leisure, and this was consumption goods, right? So this is something positive. Consumption goods are positive, right? So as you move away from the origin, utility goes up. With consumption, utility also went up. This is what we used to derive labor supply curve in chapter 2, okay? So positive impact, right? And if you move these directions, it increases. So how we do it is, based on the origin of these arrows, you draw a convex function. This was the indifference curve. This was utility level 0. So what happens if something is negative? I'm going to teach you. So I'm going to teach you how to draw actually this indifference curves, okay? So that's where we are going. I briefly showed you. Okay, so you have wage rate. You have here risk of job. This is the origin. So wage rate goes up. My utility goes up away from the origin. However, with risk, the less risk is better. The less risk. So the lower the risk, higher the utility rate. Therefore, make sure that you're going away from the origin to the other side. So this is how to figure out the shape of your indifference curves, okay? So now new origin is here, you need to draw indifference curves this direction. However, you can't have it in this plane. So move them to this side. I'm just teaching you how to actually draw indifference curves in this plane where one of the things are not desirable. So this is positive, arrow this way, negative arrow this way. And then it's going to be convex. The indifference curves will be convex to this origin, right? Fake origin we created. Move them all to this plane, U0. This is lower utility, higher utility. As you move this way, your utility will go up. In this case, remember, as you move this way, your utility northeast, your utility went up. In this case, it's going to be to the northwest. Okay, let us continue. So N is the negative aspect of a job. This could be riskiness of the job. It could be job noise or any aspect you would consider negatively. It could be the temperature at the job. For instance, I know that there are some construction areas, some manufacturing areas where the temperatures go really up high because workers deal with steel molding. Okay, just example. And W is the positive aspect, the wage rate. Indifference curves reveal the workers' preferences between wages and risk. So the question is like, why can't we have all job risk-free, right? We care about the well-being of workers. However, it's not very easy to sometimes decrease the risk of a job. It comes with the job, comes with the territory, okay? So firms may have a risky work environment because it's less expensive to pay higher wages than to make environments safe as well. So it comes with the job, but also it's more expensive to make it actually safer than to just pay people more. Okay, so indifference curves, we already learned about this. Indifference curves relating to the wage and probability of injury. We have wage on the y-axis. N is any unpleasant aspect of a job. In this case, it's the probability of injury. 0, one extreme, 1 is other extreme. So again, utility depends on wages. Positively, wages go up, utility goes up. And it depends on the probability of injury or risky aspect of the job negatively. Probability of injury goes up, your utility goes down. So utility is increasing in wage, like I said, increasing in wage. And it's decreasing in the negative aspect, probability of injury of the job. Okay, so positive, negative works this way. We just derived it in previous slide. So you are looking at indifference curves that are convex to here but move to this plane. So boom, example, U0 is a level of utility. All points on U0 will give you the same level of utility. So if basically this tells you if the probability of risk goes up from low level, let's call this point A, to a higher level, okay, you're going to demand higher wages. And that's going to just compensate you for the higher risk you're getting. U1 is a higher indifference curve, U2 is a higher indifference curve. So you're going to want to be in a higher indifference curve. So you want a job with the highest wages and the lowest probability of injury. So slope of this indifference curve is going to be dW over dN, right? So holding the utility constant, slope is positive, okay? So which means as the slope increases, people are getting more and more sensitive to risk. So here they're less sensitive, slope gets higher, they're going to be more sensitive. Actually, it's more like a comparison between two people, okay? So this individual, you person A versus you person B, they have different risk tolerance. Evaluate these two different type of person. Person A's indifference curve steeper. This person is more sensitive to risk versus person B, flatter indifference curve. this person is less sensitive to risk. Okay, so this is more of a risk lover, this is more of a risk aversive person. All right, different workers have different work preferences. Worker A is very risk averse, very sensitive to the risky aspect of the job, doesn't like risk, that's more like me. And worker B doesn't mind risk very much at all. How do we know this? You can actually show this easily. This is the initial risk and 0, and wage combination, let's say they are starting. This is wage 0, both of them. So imagine an increase in the risk to N0 to N1. Okay, so this is change in risk. Okay, so let's go hit the first individuals. Let's go hit person A's indifference curve. Okay, so person A requires her wage to go up to this level from W0 to W1. Okay, that's a lot, right, for this person. So person A basically says, you're going to increase my risk by this much. I would like this much of a hike in my payment, versus person B, right? Start from this new risk level, go hit person's B's indifference curve. Okay. Person B is not asking for much of a raise compared to, this is wage 1 person B. So this is the kind of difference person B is looking. So person A requires much more of a wage hike for the same amount of increase in risk than person B. So that's how we know they are more or less risk sensitive. Okay, let's get started. Let's put everything together. But before we put everything together, we're going to focus on ISO profit curves. So now we're relating wage and the probability to injury in terms of company profits. An ISO profit curve gives all the risk wage combinations that yield the same level of profits. ISO means equal, ISO profit equal profit. So profit pi depends on not only wage rate but also risk level. Risk level goes up, profits actually go up in the sense that it's expensive to reduce the negative aspect of the job. Example. So for instance, we are at the airports, all those crews on the plane landing and taking off, the tarmacs, they have to wear, right, one earplugs and also big earplugs as well. So imagine if we wanted to completely reduce the environmental noise. So you need actually even more expensive gear. So reducing the negative aspect of the job is costly. So the more negative aspect of the job is going to be higher the profits. Wages go up, profits go down, right? That's the input cost. So it's a little bit like two forces moving different ways. So wages on the y-axis, probability of injury on the x-axis, right? Higher wages reduce profits. It is costly to decrease negative aspect of the job. Job risk, noise. For instance, at airports, how are you going to make airplanes quieter? Impossible. So slope of the profit function, wages with respect to the risky aspect of the job, is negative of marginal cost of the negative aspect of the job divided by marginal cost of wages. Marginal cost of wages, negative, negative sign, positive. Marginal cost of n is positive, so you get positive relationship, right? So it's going to be an upward sloping situation. So profit function is going to look not this way but this way. Okay, so this will be your indifference curve. Profit functions will be looking this way. So how do we decide on this, right? How do we decide the shape of the profit function? So profits are decreasing in wages, so go away from the origin to the south to show that direction of the profits. Probability injury is positively related to profits, so it's going to be like positive movement. So profits will look like this, again, convex to this modified origin. So you put it this way, profit 0, And also they will increase as you move this way. All right, so profit 0, this is the ISO profit 0 curve. Pi 1, higher profits. Pi 2, higher profits. Do you see that? As you move from pi 0 to pi 2, your relationship is similar, right? Wage, probability of injury relationship is similar. However, you're having more and more profits in this direction. All right, so higher ISO profit curves yield lower profits. So this is a lower profit. They increase in the southeast direction. Profits increase in the direction of the arrow. Okay, so there's a risk level N star, right? So it N star in pi 2 level, the same risk level. Here you can pay lower wages. Same risk level, you are forced to pay higher wages. This is going to be lower profit. And of course, finally, at the N star risk level, look at this with the lowest ISO profit curve, you're forced to pay even the highest wages. Okay, so a firm offering, this is exactly what it said, a firm offering a risk level N star can make a workplace safer only if it reduces wages while keeping the profits constant, so that ISO profit curve is upward sloping upward. So that's why, you are having the highest profits in this ISO profit curve, and they're upward sloping. All right. So employers, these are companies, they are going to look at their ISO profit curves. ISO profit curves for firms with zero economic profit is what we're looking for. Okay, so these are different types of economic profit. Zero economic profit. What do you mean, Dr. G? So zero economic profit means actually you're getting normal rate of return to all your inputs. Normal rate of return. In microeconomics, you learned about the opportunity cost. We not only paid for every explicit cost, we also paid for the implicit opportunity cost of the resources you put in the business, such as your time, your capital, your machinery, and your also rental space, all that stuff. So imagine a company, pi y equals 0. This is one company. This is another company, pi x. Two different companies with different steepness to their profits. Okay. So again, zero economic profit. In this case, remember, this business is making normal accounting profits. It's a normal rate of return. So two firms, if you look at these two firms, what's the difference between company Y and company X? Let's consider these two firms here, pi Y and pi X. This is the ISO profit curve for company X, ISO profit curve for company Y, zero economic profit. So it is cheaper for firm X to get rid of the negative aspect of the job. How did we know this? Okay, so start from, let's say, here. Okay, so let's say we are at N0 initially. We want to decrease the negative aspect of the job by 1 unit. Okay, so initially we are paying W0. Both of them are paying W0, both X and Y. So I want to decrease the risk level by 1 unit. Boom. So this is company Y's wage change requirement. W1Y. That's 1. And let's take a look at company X's wage change requirement from N0 to N1. Start from here, go hit the company X's ISO profit curve. So it's somewhere, it's a tiny change from W0. So this is W1X. Okay, so as you can see, you have this much change. So W change in WX for company X is much less than change in wage rate for Y. So what's going on? because it's cheaper for firm X to actually get rid of the negative aspect of the job. So to reduce N, costs must increase, right? Must cut other costs to make the same profit. Which one needs to cut wages less to make the same profit? To reduce the risk by 1 unit. We reduce the risk by 1 unit. Which one has to cut wages less to make same profit? Marginal cost of reducing risk is lower for firm X compared to Y. So therefore, to decrease the risk, X doesn't have to cut the wage by a lot. That's what it means. Company X can easily cut the risk without having affected the wage rates, without having affected the labor. Okay, let's continue. Hedonic wage function is where we put everything together. So different firms have different isoprofit curves. Different workers have different indifference curves, right? So hedonic wage function is basically puts everything together. The labor market marries workers who dislike risk, such as worker A, remember, with firms that find it easy to provide a safe environment, like firm X. Look at this. Worker A, worker B. So how do I know who likes risk more? Worker A, do you see it? Worker A has just, this is the key, folks. This is a little trick. Make sure you extend both indifference curves such that they intersect. At the point they intersect, the steeper indifference curve, steeper one, is going to be the person who disliked the risk. Flatter one, relaxed. Flatter, relaxed. Who doesn't mind risk? So let's take a look at companies. Well, we have another worker. Worker C is even more relaxed than worker B. Okay? Doesn't mind risk at all. And then we have companies. Company X finds it very easy to reduce risk. Company Y finds it a little bit harder. How did we find? Extend their isoprofit curves. Flatter will be easier to reduce the risk. And you're going to have a steeper one, harder to reduce risk. Even another companies here. Again, extend them to find who finds it easier to reduce risk. Let's go back to this graph, right? Remember, company X finds it easier to reduce the risk. Okay? So X is easier to reduce the risk compared to Y. Y is relatively more easier to finds it relatively easier to reduce the risk compared to Z. Okay? So once you marry these people, match them. Okay? So PA is a worker company combination, creates the wage rate and the risk level. PB, another company worker combination. PC is another company worker combination. So hedonic wage function is the locus of all these company worker combinations with different wage rates and different risk levels. Workers who don't mind risk very much, such as worker C, will find a job at companies that find it difficult to provide a safe environment, like firm Z. And workers who don't like risk will find companies such as company X that is easy for them to provide safer work environment. So the observed relationship between wages and job characteristics is called hedonic wage function. Check this out. Wage rate, wage, call it A. This is the risk level A, low risk level, lower wages, little bit higher risk level, higher wages. This is W, and you have highest wage rate for even higher risk level. Okay, so the theory says positive compensating differential arises, which means higher the unpleasant side of the job, side effects or aspect of the job, higher the wages that it should command. Okay? So hedonic wage theory in sum, workers maximize utility by choosing wage risk combinations that offer them the greatest amount of utility. Risk could be, for instance, risk of losing the job, probability of losing the job. For instance, I have graduate school friends who actually didn't become professors. Professors get paid relatively less compared to, let's say, hedge fund manager. One of my friends went on to live in New York City, started working at a hedge fund. Then he was making 3 times as much as I made. Okay. I graduated. This is my second job after PhD. He has changed so many jobs. There's the risk, but he gets paid more, right? So that's the risk wage combination. Isoprofit curves are upward sloping because production of safety is costly. Isoprofit curves are concave because production safety is subject to the law of diminishing returns. What does it mean? At the lower level of production of safety to protect ears, right? You can actually put earbuds if you're working on the tarmac of an airport. Earbuds, another layer. But if it becomes even more, dangerous, let's say, new research, this is totally made up. New research shows that we can't even stand 40 decibel, which is very low sound level. So then it becomes really costly to produce actually the very silent airplanes. The cost climbs. Hedonic wage functions reflect the relationship between wages and job characteristics. And I will see you in next part where we discuss government regulation in the market for risky jobs and or jobs with negative attributes. I'll see you then.